Next we have our question number 33, which is similar to question number 32. So in order to remove this square root, we have to multiply this with 1 minus sin a to the numerator and to the denominator as well. So here we'll be multiplying with 1 minus sin a by 1 minus sin a, and this should be under root. And here we have 1 minus sin a and 1 minus sin a, that is 1 minus sin a whole square. And denominator is in the form of a plus b into a minus b, which is a square minus b square. And we know our identity that cos square a can be written as 1 minus sin square a. So I'll write this as 1 minus sin a whole square by cos square a. So for the square and root we can calculate this. We'll get it as 1 minus sin a by cos a. So this we can divide it into two terms, that is 1 by cos a minus sin a by cos a. And we know inverse of cos is nothing but secant a, and sin by cos is tan. Next we have our question number 34, which is in the form of cot and cosecant, and we need to get in terms of sin. And if we observe this numerator, we have one identity, that is cot square a can be written as cosecant square a minus 1. We have one identity, so I will replace this numerator with cosecant square a minus 1 by this denominator remains same as of now. And here the numerator is in the form of a square minus b square, which can be expanded as a plus b into a minus b. And here it is a plus b whole square, which can be written as a plus b into a plus b. So I'll divide that into two different factors. So here these two factors gets cancelled, and here we can write this cosecant as inverse of sine. We can write this as inverse of sine. Cosecant can be written as inverse of sine, and here we will be taking the LCM of this. We will get 1 minus sin a by the denominator is sin a, and here we will get 1 plus sin a by sin a. So we can cancel this both sin a values. We will get it as 1 minus sin a by 1 plus sin a. Next question number 35, here we need to get our answer in terms of cos and sin. In LHS, all the values are in terms of sin and cos except the tan. So we'll change the tan in terms of sin and cos. This can be written as 1 minus sin a by cos a. Right? So the second term of the numerator LHS remains same. Next, take the LCM here. We'll get it as cos a by cos a minus sin a, and the denominator. So we can write this here, and as usual the second term remains same. We'll get it as sin a minus cos a in the denominator. Now transpose this cos a to the numerator. Cos a into cos a, will get it as cos square a. Cos square a by this denominator remains same, and we have our second term, which is sin square a by sin a minus cos a. Next, here we have cos square a minus sin a, and here it is sin a minus cos a, that is a minus b and b minus a. Just take any term as a common from here. So we can take out sin a minus cos a as common, or cos a minus sin a as common. So as of now I will take it out. Cos a minus sin a as a common term, will get it as cos square a minus sin square a, and here it is in the form of a square minus b square. Expand that in a plus b into a minus b. We will get cos a plus sin a into cos a minus sin a, and the denominator remains same, which is cos a minus sin a. So here we can cancel out these two terms. Our remaining answer will be cos a plus sin a. Next we have our question number 36. So here convert the tan and cot in terms of sin first. We'll get 1 minus sin theta by cos theta by 1 minus cos theta by sin theta whole square. Right. So here take the LCM of this. We'll get cos theta minus sin theta by cos, and take the reciprocal of this. So okay, next term we can do it. Sin theta minus cos by sine, and these are the two numerators and denominator whole square will get. So here we can write it as cos theta minus sin theta by cos, and here we can write sin theta by sin theta minus cos theta. If you observe, here we have a minus b and b minus. So I will take out negative sign as a common from any one of these terms. I will take out minus sign. Here we'll get sin theta minus cos theta, and here we have whole square here by cos theta into sin theta by sin theta minus cos theta whole square. So here we can cancel out these two terms. Our remaining values are minus sin theta by cos theta whole square. And we know sin by cos is nothing but tan, minus tan theta whole square. So minus tan theta whole square is nothing but tan square theta. Minus of minus is plus. Next, question number 37 we have, convert the tan in terms of sin and cos first. This first term remains same, cos A by 1 plus sin A, and the tan can be written as sin A by cos A. Now take the LCM of this two denominator, that is nothing but cos multiplication will do. Cos square A plus sin of 1 plus sin A, and in denominator we'll get the product of two denominators, that is 1 plus sin A into cos A. Now multiply the sin A to the terms inside the bracket. We'll get cos square A plus sin A into 1 is sin A, and sin of sin is sin square A by 1 plus sin A into cos A. And we have one identity, cos square A plus sin square A gives 1. We'll get 1 plus sin A by 1 plus sin A into cos A. Cancel out these two terms, we'll get it as 1 by cos A, which is inverse of cos is nothing but secant A. Next we have our question number 38. First we have sin and cos. So change this tan and cot in terms of sin and cos also. This first term remains same, and this tan we can write it as sin theta by cos theta, and cot can be written as cos theta by sin theta. Now take the LCM of this second factor, whereas the first factor remains same. We'll get it as sin square theta plus cos square theta by, the denominator will be product of two denominators here, and we have one identity, sin square theta plus cos square theta is 1. So here we'll be getting it as sin theta plus cos theta by cos into sin. In numerator we have two terms. Divide that into two different terms. We'll get it as sin theta by cos into sin plus cos theta by cos into sin. Here we can cancel out the common terms, sin and sin, cos and cos. We'll be having inverse of cos plus inverse of sin. Inverse of cos is nothing but secant theta. Inverse of sin is cosecant theta. This question number 39. Usually we'll solve our questions using LHS, and we'll convert that in the form of RHS. Whereas for this question, we'll simplify our RHS value. Let's take our RHS value, which is 1 by sin square A minus sin power 4A, and write this 1 as our identity, which is sin square A plus cos square A. And from here you please take out the sin square A as common. We'll get it as 1 minus sin square A. And from our identities we know that 1 minus sin square A is nothing but cos square A. Now replace this with cos square A. We'll get sin square A plus cos square A by sin square into cos square. Divide this into two different factors because we have two terms in numerator. So we'll be writing it as sin square A by sin square A into cos square A plus cos square A by sin square A into cos square A. Cancel out the common terms here. Cos and cos gets cancelled. We'll be having inverse of cos square A plus inverse of sin square A. Inverse of cos is nothing but secant square A, inverse of sine is nothing but cosecant square A. And we have our identities. Secant square A can be written as 1 plus tan square A, and cosecant can be written as 1 plus cot square A. So here I'll write the secant square as 1 plus tan square, and here we have plus relation between, and cosecant can be written as 1 plus cot square A, which is our required LHS. Next, question number 40, here we have, in LHS we have the square root, and we know in order to remove the square root we need to have any square term. So we'll simplify this LHS. From our identities we can write our secant square as 1 plus tan square, and this cosecant square can be written as 1 plus cot square. So replace these two values with this, we'll get it as 1 plus tan square A, and cosecant can be written as 1 plus cot square A, right? So 1 plus 1 is 2 plus tan square A plus cot square A. If we observe this, it is in the form of A square plus B square plus 2AB. Tan A into cot A is equals to 1, because this cot is nothing but inverse of tan. So this cot A into tan A can be written as 1. So it is in the form of A square plus B square plus 2AB, which is A plus B whole square, which is tan A plus cot A whole square. So now we can cancel out the square and root. We'll get it as tan A plus cot A. So next, question number 41, we have, convert all these terms in the form of sine and cos. So first, tan can be written as sine A by cos A, and cot can be written as cos A by sine A. And write this cosecant as inverse of sine, and leave the sine as it is, and write the secant as 1 by cos, which is inverse of cos. Now take the LCM of this first term, that is cross multiplication. We'll get it as sine square A plus cos square A by cos A into sine A. Now take the LCM of this second factor, we'll get 1 minus sine square A by sine A. And repeat the same but the second, third factors, we'll get it as 1 minus cos square A by cos A. And here we'll be using our only one condition, which is sine square A plus cos square A is equals to 1. This we can write it as sine square A is equals to 1 minus cos square A. Similarly, cos square A is equals to 1 minus sine square A. Now use the three identities to replace this numerator. Here we'll get 1 by cos A into sine A, and here we'll get it as cos square A by sine A, and this we can write it as sine square A by cos A. Here we have square. For the square, this two cos values gets cancelled, and for the square, this two sine values gets cancelled, which is our remaining answer is 1. Next we have our question number 42. Here we have the numerator in the form of a plus b whole square plus a minus b whole square. We know one condition from our algebra, which is a minus b whole square is 2 times of a square plus b square. Now we'll just simplify this numerator in this form. We'll get it as 2 times of 1 plus sine square theta, and by this 2 cos square theta remains same. Cancel out this 2 and 2, we'll get it as 1 plus sine square theta by cos square theta. Expand this into two terms, we'll get inverse of cos square plus sine square by cos square, and we know inverse of cos is secant square, and sine square by cos square is tan square.